We are all here today because of a relationship that we had with water. And just like any relationship, they change. Good relationships are dynamic. Realizing that the only constant in this great life is change. That's really the why of this gathering here today, coming together with our unique passions and potential and sharing that with one another, building deeper connections, finding new energy, and ultimately coming back to our work refreshed, inspired, and changed. Sometimes all it takes is the slightest shift, a new reframe of life, and our minds are opened up to a whole new pathways of perception, teeming not with barriers, but with possibility. A small shift, that's all it takes, in our energy and focus, and uninspired relationships are infused with hope. It is with such great excitement and honor that I get to introduce our keynote speaker today. The founder of Oregon State University's Permaculture Design Program, Andrew Millison is an international leader in permaculture design and education. A world traveler and documentarian focused on innovative water management and earth regeneration systems. The owner of a wildly popular YouTube channel. If you haven't checked it out, I encourage you all to do so. For over a quarter of a century, Andrew has been building dynamic water relationships, sharing earth sciences in an artistic and edutaining way that inspires people to make real change in their worlds. A superhero of information design to me and to so many others. Let's give a round of applause to Andrew Millison.
All right, thank you so much for that introduction. And I've got to say that when Kelsey approached me to give the keynote here at the Washington Municipal Stormwater Conference, I was so honored. I was so excited because, in my world, in my belief, stormwater management, well done stormwater management, is really the foundation for a healthy society, a healthy civilization. So, when I was asked to do this, I was so excited. I ran over to my wife and my family. I was like, you won't believe it. I was asked to keynote the Washington Municipal Stormwater Conference. This is crazy, right? My wife was like, ooh, wow, honey, that sounds really fascinating. It's gonna be crazy, right? Like what happens in Wenatchee stays in Wenatchee. I was like, no, you don't understand, right? This is not boring. This is super exciting, right? And like my wife and my son, they kind of laughed at me. They're like, yeah, okay, exciting, right? And I had to think about it, and I was like, well, I guess if you're doing stormwater management in the conventional sense, channeling water from source to sink through concrete lined channels, I've got to say that, I can't blame them, right? So how many people here actually give a hand up if your husband, wife, family, partner really would actually agree with my family and think that municipal stormwater management is kind of boring? Okay, I see a lot of hands there, right? So can we blame them when this is the public's image of stormwater management? But what I'm here to say is that stormwater management, municipal stormwater, is a fascinating topic. When we look throughout history, we see many amazing examples. I've spent a lot of time in India. I've visited a number of step wells that are collecting the runoff from the surrounding area into these geometrically designed water storage reservoirs where people are, the water level fluctuates throughout the year and people are going down, they're dipping water in here and bringing it back home historically for their domestic water supply, right? Or when we look at some of the Roman underground cisterns, beautiful columns and archways that are collecting the runoff from vast areas of cities and putting them down for ancient people's water supplies. We see these same types of systems in Morocco, ornately done, where stormwater management is an art and a craft, right? And really is the foundation for the infrastructure of the whole society. The Persian Khanate lines, right? Now, this isn't actually so much municipal stormwater. This is actually a little more groundwater management, where they dug these shafts at the base of mountains where there's a water table and created underground tunnels that ran very far. In fact, on the Iranian plateau, there are 250,000 miles of these underground water tunnels that end up in villages and for agriculture. And it's actually called the largest municipal water project in history in the ancient world, right? We've got the beautiful Roman aqueducts. Again, these aren't necessarily stormwater management structures, but they're beautiful, ornate, thoughtful, artistic, creative water management structures. The Inca Empire, how did they bring water through all of these great terraces, Machu Picchu? These are all very thoughtfully, beautifully designed by artists, craftspeople. Petra, Jordan, right? This is in the desert of Jordan, a place that gets about 2 inches of rainfall a year. There's an entire city that's carved into the rocks, and the whole water system that allowed the city to be there was from runoff flowing down into these water channels, into these small reservoirs, and feeding the entire city, right? So we have so many examples of beautiful and incredibly artistic, even in Seattle here, where all this energy went here into Vine Street to really try to show the public how stormwater can be craftily moved and, you know, to bring the public's attention to the beauty of water movement, because so much of our society, we're hiding water underground, and the water movement, municipal stormwater drainage, is an afterthought. So how many people here are from Seattle, actually? Okay, is anybody involved in this project? Yeah, a little bit. Okay, excellent job. The Beckoning cistern in Seattle, right? This cistern that is shaped like a hand that then spills over to these pools in this beautiful artistic way. I mean, this is not boring. This is really beautiful, intriguing, and fascinating stormwater management. And this is the kind of stuff that inspires me. And I hope that it can also inspire some of you. It's not just beauty, art, inspiration that we can get from these things. Also, there's incredible utility around the world to many different stormwater management structures. This here, I've spent a lot of time in Rajasthan here. You can see this is a tanka here. The water from a small area will be collected, and it goes through this little zigzag here in order to settle out any solids and sediments. And then the water goes into this underground tank, usually about 10,000 liters. Now, here's a place where the presence of stormwater management is actually has a really big social impacts, because if you don't have one of these systems for your home, you're probably not going to be able to marry off your son or your daughter, right? Because here, the presence of water means that if you have one of these systems, your children, your daughters, don't have to spend hours a day walking with pots of water on their head to another water source. So if you have a son, you know, marriage is here arranged between parents. If you have a son, and traditionally when you marry your son off, someone sends their daughter to you, right? People do not want to send their daughter to your family because they don't want them to have to walk for hours a day collecting water. So here, stormwater management has direct social repercussions, right? So, you know, it's a big field. And in permaculture, we're looking at not just stormwater management structures as these isolated pieces of infrastructure. We're looking at how they integrate into many other elements. Okay, so permaculture, for those of you who haven't heard of it, is a design system for creating human settlements, right? So we're talking about water, we're talking about roadways, we're talking about structures, trees, fencing, right? All of the things that go to surround what we think of as, the things that people need to live for their basic livelihood, right? So it's a design system for creating those things. And water management is the bones of that system. So when we're designing a system, the first thing we design for is how are we going to manage and move the water through that landscape? And then how are roadways, pathways, structures, trees, gardens, fencing, recreation, public areas, how are those going to be overlaid from our base of water, of our water management design, right? And so this is in permaculture, stormwater management is definitely the foundation of any system that we're designing, right? And it's all about integration. Okay, and this is the main takeaway that I'm going to want to impart to you for this talk is how do we integrate stormwater design, municipal stormwater management? How do we integrate it and actually have it create the basis for many other benefits that we can get? Okay, so there's many different scales from the urban to rural of how we can design around stormwater first. Okay. So let's talk specifically about Washington. Now, Washington has a number of different climate zones. This is the Köppen-Geiger climate map here of Washington. And we can see, that we've got dry areas. Basically, the Köppen-Geiger map is going on rainfall amount, rainfall timing, and temperature. Right. So for the purposes of this presentation, let's just look at rainfall amount. Here's the rainfall map of Washington. And to simplify this, because we have limited amount of time, let's talk about dry Washington and wet Washington. So how many people in this room are from the dry side of Washington? So we'll start with the dry side here. And let's talk about how permaculture would view urban design in the dry side of Washington. Now, I'm going to share an example. This is actually one of my teachers, and this is a project that I've been visiting since 1996 when I first took a course here in Tucson. Now, Tucson, as many of you know, has about 10 to 12 inches of rainfall per year, similar to a lot of areas of dry Washington. Now, Brad Lancaster, he has been working since the early 90s to, as basically a citizens initiative to infiltrate stormwater into his neighborhood in Tucson, Arizona. And the basic premise, he actually started out illegally, cutting the curb without permission from the city, cutting the curb where the storm is running off in the gutter next to the road, and creating basins and planting trees, right? And the very simple marriage of trees and stormwater runoff. And he planted native trees that really love the benefit of just a little bit of extra water, mostly mesquite. And you can see in the lower left there, the results of his stormwater only plantings by the sides of the roads. I mean, it seems very simple now, but it was actually a bit revolutionary almost 30 years ago when this project started. And yes, you're growing trees, you're creating all this wonderful native habitat, you're absorbing stormwater. But one of the main effects was this mitigation of the heat island effect. I mean, if any of you have ever been in Tucson in the summer, well, it's actually a bit similar in temperature to Wenatchee in the summer, right? I was told that Wenatchee easily can get up to 109 degrees in the summertime. So this is an infrared camera from city streets in Australia. So I put in the Fahrenheit there, but this is done in Celsius. And they did measurements here in the height of summer. and saw that the pavement underneath trees, 94 degrees Fahrenheit, it's extremely hot out here. And then in the open blacktop, in the beating sun, it could be up to 142 degrees Fahrenheit. So we're talking about cooking your food on the open road. That's how hot. So, I mean, look at the temperature differentiation here between shade and sun. So especially in a hot climate like Tucson or like Wenatchee, just that marriage of stormwater and trees to mitigate the heat island effect. I mean, that's all the integration you need, basically. Now, when we jump out to the rural areas, we can have a similar relationship between runoff and tree growth. Again, I'm showing you some extreme examples. Here is the Negev Desert in Israel. This is an area that receives about an inch of rainfall a year. So maybe one storm a year or two storms a year. It's a very barren area, which means you have a huge amount of runoff. So all they did was place this basin here in a point that was going to collect a lot of runoff from the surrounding environment and planted hardy native trees that could survive off of that extra runoff coming. And they grew these trees here, and there's real effects by just simply digging a hole in the right place and putting in some hardy plant species. So, groundwater recharge. If you have a series of structures like this, where throughout a watershed, you're infiltrating water and it percolates in, it no longer is running off. So you have groundwater recharge, you can control erosion, and then through the plants, you create habitat, biodiversity. So we start to get a lot of these integrated effects through just a simple structure. Now, when we think of groundwater recharge, right, we think of the way that water moves through the watershed. These watershed basins are in the pattern of trees, these small branches combining, leading to other branches, leading to bigger branches. And when properly placed, right, so we could see incredible effects when we're slowing the movement of the water through the watershed, through that watershed tree. Now we can see that in nature here. So this is an image from Nevada of a valley where beavers came in and began to build beaver dams. And those beaver dams essentially are just changing the duration of time that it takes for water to move through the watershed. And that's the foundational pattern when we're talking about watershed scale work for stormwater management. We're just doing what the beavers are doing. We're just creating a pause, a place for the water to slow down, soak in, and suddenly water tables fill, vegetation grows, the ecosystem regenerates, and all of these incredible effects happen from that. So in a lot of ways, when we're looking, back at a system like this here, like this in the Negev Desert, really, we are just acting as the beavers in a landscape that doesn't have those. And, in many cases, just letting the beavers return could be all of the watershed work that needs to happen. So let's jump over now to the wet side of Washington. How many people here are wet side people? Okay, all right. More wet side people than dry people. Let's see here. So jumping over the wet side. Now this is a familiar site right here. Right? I mean, we see structures like this all over Seattle, Portland, and these is really spread throughout many places I've gone in the Northwest, urban stormwater basins. Now, one of the things that actually really bothers me about a lot of these basins are the plant choices, especially when I see exotic, ornamental, high maintenance plants put in these basins. Because we're creating this structure, we're just creating the same thing I showed you with Brad Lancaster creating in Tucson. It's just a little place in the curb, cut where the water goes into a basin. But I know for a lot of people in your field, the management of these systems are creating a lot of work for our landscape management teams. How practical are these, right? So the creativity of what we do with a system like this really is going to depend, especially in your case, on what is the cost of maintaining these systems, okay? But when I see a system like this that is planted in, kind of exotic ornamentals, the thought that always comes to my mind is, why are we not just using hardy native plants that require very little maintenance and also provide a lot of ecosystem services, right? Ecosystem services are the many and varied benefits to humans provided by natural environments and healthy ecosystems. So I want to flip the script a little bit and say, ask not what you can do for your ecosystem, but what can your ecosystem actually do for you when you get it started, when you jumpstart ecosystem services and processes by creating native ecosystems in a bioswale like that. Now, when I was walking around Wenatchee the last couple of days, and I was looking around, I was like, I would bet that if all of the stormwater in the streets around here was going into vegetated bioswales that were throughout the city, and all the water was going in and feeding this diverse matrix of low maintenance native plants. Right? I was just imagining the pollinators that would then have this permanent food source, right? You'd have all of these pollinators all throughout Wenatchee that had all of these different flowers, and things were flowering at different times. And so you're supporting this whole ecosystem of predator and prey relationships. And I was like, well, I wonder if you could get enough of an ecosystem services in Wenatchee from native planted stormwater basins to actually provide pollinators for the surrounding orchards, right? I mean, why not? It's just an idea, but this is kind of the level when we're saying, what can your ecosystem do for you? That could actually lower the costs. I also was doing a little research, and I just typed in, orchard pollinators Wenatchee, and there was pictures of, big machines going that were basically doing machine done pollination, right? So it made me think like, wow, maybe there's a pollinator issue here, and that might be solved by proper stormwater management. So these are just some of the connections that we start to make. Especially when we're looking at trees. I mean, trees, we've got shade and temperature reduction, as we've shown. We've got flowers for all different types of pollinators, recreation. I mean, like, raise your hand if you have a kid that spends or has spent significant time of their life up in a tree, right? Okay, my kid basically lived in a tree until he was about, started on a skateboard. Swings, climbing, fruits, nuts, habitat for birds, squirrels, wood products, wind reduction. Okay, now, I know a lot of you, the first thing when I said tree, the first thing you thought of was ice storms, wind storms, destruction, right? And yes, trees have the capacity for this, but we also have a lot of information. So this is a list I just Googled. Washington ice storm resistant trees, and WSU, of course, had this wonderful list that showed susceptible, intermediate resistance, and resistant trees to ice storms. So, a lot of this is just about plant selection for the practicality, the management of these types of systems. Because everybody loves tree-lined streets. This is WSU again. Most of the places that people consider quaint in the world that we want to go visit and we want to walk around with our families are wonderful shady tree-lined streets. Right? So, I mean, in my opinion, the whole community benefits from tree-lined streets. So, that marriage of stormwater and trees, I think it's just huge integration piece. So let's look at a few examples of places that were actually designed intentionally from the start with this in mind. So this is Village Homes in Davis, California. Anybody here been to Village Homes in Davis, California? Okay, a few hands. This place is spectacular. It was built in the early 80s, and it's a residential development that was designed around stormwater first. Okay, so this is a map here, and I'm going to use the mouse to just show you a little thing here. So you can see here the cul-de-sacs, right? And so we have the cul-de-sacs, and then we have the homes that are clustered here around the cul-de-sacs. And then we have the next cul-de-sac up here and these homes that are clustered around the cul-de-sacs. And then in between those homes here, we see this path. Okay, and in between each cul-de-sac, we have this path between the homes. Now that path is not just a pedestrian path. That is a big giant swale, a big giant water collection basin. Now, before I go to the next slide, I want to also point out that all of these homes, all of these roads are elongated east to west. So by design, all of the homes are oriented for good passive solar energy, which reduces their energy costs, reduces their lighting needs, reduces their heating and cooling just by the home orientation. Okay, so this is what it looks like between those homes. All of the water from all of the houses, from all of the roads, from all of the paths, all the hardscapes is collected in these basins, and then a nice pedestrian pathway is going through there. And these basins are planted. I mean, you know, the Central Valley in California, you can grow practically anything. They're planted so densely in food plants that when I was there, I literally just closed my eyes and opened my mouth. And I walked through here and food just fell in my face, grapes and figs and I mean, pomegranates. It was incredible, right? And this place is not only resistant, you can imagine how it's resistant to drought. Every time it rains, this high concentration of water from all the hardscape is going into these basins. It's infiltrating in, it's feeding this perennial vegetation that are establishing deep roots. And so when the Central Valley of California goes into its regular drought period, there's a lot of moisture retained in the soil here. They built this subsurface water table under this community. It just doesn't dry out under there. On the flip side, when there's flood, the infiltration in these basins is so great because of all this extensive root network and the fact that there's this place for the water to flow into and the houses are up on raised areas is they also had no problems when there's been periodic floods here. So a system like this actually both is resistant to both drought and flood. Okay, now I'm going to give you a similar sort of example. We're going to flip over to the desert for you desert people. Again, back to the Tucson area. Tucson's very progressive with stormwater management. This is Milagro Cohousing. This is a 40-acre site. Instead of taking the houses and spreading them all around the site, creating lots of roadways and more hardscape, they clustered the houses and clustered all the parking, right? And made it so everybody could leave their home and have access to the desert, right? And when they built this community, they built it around stormwater infrastructure first. So this is right after they constructed this, before they did any of the plantings here. These are the basins inside the community, and each basin, all of the stormwater from the pathways, from the homes, it's all diverted to these basins. When it rains, the basins fill up and they overflow one to the next, okay? So all of the water is concentrated in the center of the community. So they're basically at least doubling the amount of rainfall that comes into the center of this community here. Not only that, but all of the homes, again, are placed and designed to have good passive solar access, right? So all of the homes, they're basically an adobe with windows on the south side. And when it's sunny out in the wintertime, the low sun heats the interior of the homes. And in the summertime, the sun is excluded from the windows and they save on energy, they save on lighting, and it's very comfortable, right? So here we see the integration of passive solar design, water catchment, and then we add in wastewater reuse, recycling. So then they take all the wastewater of the community, they run it through a constructed wetland system, and then any excess is then used for further irrigation. Right? So, I mean, this is integration. Like when I'm talking about permaculture is integration, this is taking three basic elements, putting them together and creating a system. I mean, this thing is incredibly pleasant for the people that live in this community. I mean, I've walked through here. It's really nice. It's all under this beautiful shade canopy. They've got fruit trees everywhere. Kids are running around. It's cool. There's swings. People are gardening. They've got cisterns. It's very nice, right? And, you know, think about if you're wandering through the desert, where is the nicest place to be? Right? What are you looking for? What is like the holy grail of desert? Shade, water, right? A canyon. a sheltered canyon oasis. So through their development, they have actually put in the structure, the canyon walls are the homes, and all the water's channeled into the canyon there, and it's shady, and there's moisture in the air, and they're really, you know, we call this biomimicry, right? Biomimicry is a practice that learns from and mimics the strategies found in nature to solve human design challenges. So they've mimicked the pattern of a lush and shady and moist canyon, and it didn't cost them any more money, right? They had to put in grading and drainage in this community anyway. They were going to build the houses anyway. It was just intelligence about properly orienting the houses so they would have this great effect, right? So a lot of these solutions are not more costly than conventional solutions, right? It's just having the forethought and thinking about integration and thinking about how the infrastructure can be built on top of stormwater management. Now, if any of you are saying, you know, especially you dry side people, like, it's no way, come on, it's just too dry where we live here. I'm going to show you the example that will crush that idea, okay? Because here we are in Saudi Arabia, where it gets between 0 and 1.5 inches per year. It basically like might rain once or twice or not at all. And here you can see, I'm going to put the cursor on again. So we have these, this is a far off shot. We have these rows of trees. These are all planted in on contour swales that are harvesting the water that's running off of this rocky hill here. So when these storms come through, there's so much runoff because this is just impermeable rock, most of this here. And in those swales, they planted trees. This was an experiment, right? See what would live. So they gathered trees, different species, dryland species from similar climates from all over the world, and planted them and irrigated them and got them established for about 3 years or so. And they only irrigated the amount of water that they were actually collecting. So they kept within their water budget. And then after the trees got established, they turned the water off. It didn't rain for a year and a half, and most things died, but 4 different varieties didn't die, right? And so they found out what 4 tree species could live off of only the rainfall in a water harvesting basin in a place that gets 0 to 1.5 inches a year. So really, it can be done anywhere, right? So if it can be done here, it can be done basically anywhere, right? I'm going to just tell you about the most inspiring stormwater management story that I know of on the planet, and that's the Pani Foundation in Maharashtra, India, right? And I've visited their work and documented this extensively on my YouTube channel, and I just was there just a couple of months ago here, where basically there's a contest between villages to see which village could build the most amount of stormwater management structures in a 45-day period. Okay, so all the villagers went out, they had this big volunteers thing, everybody got, some people made food, and they had training, and they would take their watersheds that their villages were in and do this incredible amount of work in a 45-day period. And in the 4 years that they ran this contest, 8,000 villages participated. And this gives you a little sense of the scale of the stormwater management that they were doing. And they basically restored the water tables of about 8,000 villages in just 4 years. Now, luckily for Indians, these villages have been there for a very long time. And so naturally, the boundaries of the villages follow watershed basins. So the village commons, when they said, oh, we want to restore the land of the village, it was a complete watershed. So when they went top to bottom, they restored their groundwater in one season. 45 days, they built the structures, then they got the monsoon rains, and then their water table was restored. And this happened many, many, many times over. So, I mean, it's really mind-blowing when we see some of the things that are happening. And when we start to look at the world from the perspective of the watershed, right? So here is the United Watershed States of America here. We see the mighty Columbia Basin there, which actually goes into Canada, right? The Mississippi. And one of the challenges we face is that our municipal boundaries, our political boundaries, do not correspond to watershed boundaries, right? So anytime we're trying to work in the watershed level, especially in the United States, where we're working with property grid that does not correspond to the watershed, we have just a giant challenge right up front, you know, and I really see how starkly different it is when you go someplace like India, where a village watershed boundary, they can just restore the whole watershed. But as you all know, working in municipal stormwater, the challenges of property ownership, property management are very difficult, you know. So how do we do integrated watershed management in this, you know, in this context? I guess I would put that out to you, right? Because you're the ones that actually have to work through this complicated equation of how do we actually get the maximum wonderful benefits of integrated watershed scale management, where we restore water tables, we reconnect ecologies, we provide shade for our communities, we provide ecosystem services, we provide all these other yields when this is done well and this is done right. And this here is the model that the Pani Foundation goes when they're training the villagers. This is the model that they bring around, and then they pour water over this model to show how, when you treat the whole watershed, how it has such amazing hydrologic effects, basically. So, Oregon State University, you can find a lot of my work there. If you just type in permaculture, Oregon State University, we have courses and all sorts of things, lots of people involved. And also, I have like a lot of videos online that go into a lot of the details on a lot of these things. And, you know, each one of these topics we could probably expand out for a very long time. But I just want to close by saying that I am just really honored to, you know, talk to this group of people, because you are really the power brokers of stormwater in Washington State, you know. And so if you can just push the needle a little bit in a lot of the different projects you're doing towards these integrated systems, then, you know, the citizens of this state will see a great benefit, right? So thank you very much.